assignments so far? Any questions over anything we've done so far? Where is Kim? Oh, sorry. So used to being up there. Okay. Any questions over the homework before we get started with today's lesson? Okay. If there's no questions on the homework, we'll go on and start by looking at what we're covering today, which is inverses. So we're covering inverse functions today. Now, a function is defined to have an inverse if it passes the horizontal line test. If we can draw a horizontal line and it crosses the function more than once, then it doesn't have an inverse. It will not have an inverse of its function. Well, more specifically, not that it doesn't have an inverse, its inverse is just not a function. So we can still find it, we just can't define it as a function. Here, it only crosses once, so its inverse is a function. It's not that it doesn't have an inverse, it's just its inverse is not a function. So this function here, if we graphed its inverse, would actually be this graph here, which this one here doesn't pass the vertical line test. Because the horizontal line test is taking the function itself and seeing if it has an inverse. If its inverse is, not has an inverse, if its inverse is a function. Because once we find the inverse, this here would be its inverse, and we apply the horizontal line test to it, to actually testing to see if it is a function, it would fail. So any function that fails the horizontal line test means its inverse is not a function. That's all it's telling us. Now, we're going to look at finding inverses, and y'all have found inverses before. You've done this in Algebra 1. We're just looking at it again, especially with exponents and powers. Now, we're going to look at one of them the way that the book is having us do it, and then we're going to do it the main way that y'all know how to do these. So the first thing we're looking at for this here is to solve y equals f of x for x. So all that's saying is that we're taking the function f of x equals 2x plus 3, and first off replacing f of x with y. So y equals 2x plus 3. And what we want to do with this here is now just solve this for x. We want to get x by itself. And to do that, what is the first thing we need to do? We need to subtract 3 from both sides. Because here, 3 minus 3 would give us 0, telling us y minus 3 is equal to 2x. So again, we did move some of the terms over, and we are closer to getting y by itself, or not y by itself, x by itself. Now what would we need to do next? It is the 2, but we would divide. Because since the x is being multiplied by 2, we would want to divide to undo that. Now 2 divided by 2 would give us 1, so x is by itself, and it's equal to y minus 3 over 2. So for this one here, we did solve for the value of x. And we get x is equal to y minus 3 divided by 2. So that's half of the problem. The other half is to find the input when the output is -7. Well, with any function, the input is the values of x, the output is the values of y. So here, we're wanting to know what the value of x is when the value of y is -7. And at this point here, we could have plugged this onto the calculator, -7 minus 3 divided by 2. Or if we do this by hand, -7 minus 3 is -10. And -10 divided by 2 is -5. And that's all we have to do for this here. Questions on any of this here that we've done so far? Now, again, I find this is an odd way to do these. So let's look at the main steps that we're going to really work with for the rest of these here for finding inverses. The first main step is to replace f of x with y. We're going to replace f of x with y. Because f of x is y, it's just a way for us to denote it, and especially when we have more than one function. Now the second step is to switch x and y. We want to switch x and y. Switch x and y. Our third step is to solve for y. We want to get y back by itself. And last but not least, our fourth main step is to replace f of y with f of x squared, or f inverse of x. Gosh. With f inverse of x. And these here are our main four steps for finding an inverse, or finding the inverse of a function. Okay. So we're going to do that with this one here. I know it says solve y equals f of x for x, but we're just going to go on and use our inverse steps. Now our first main step in finding the inverse, or really that's what we're doing here, switching x and y, we're solving for the inverse. Well, we need to rewrite this as y is equal to 3x minus 5. Now what's our next step in finding the inverse? Switch x and y. So x and y switch would tell us that x is equal to 3y minus 5, because we've flipped the x and y. We've switched the input and output. Now we need to get y by itself. So what can we do next? We can add 5 to both sides, which will tell us that x plus 5 is equal to 3y. Yes, then we would need to divide both sides by 3, telling us that y is equal to plus 5 over 3. Or really we can say that f inverse of x is x plus 5 over 3. And that there is our inverse. That there is our inverse function. Any questions on any of this here? Now when we talk about inverses in these here, because we're always talking about there being a domain, the x values, and a range, the y values. And a given function, f of x, takes a value from the domain and takes it to and matches it to a value in the range. It maps it to every domain, every x value, to a range. Now the inverse function goes the other way around. It's taking those range values and mapping them or connecting them back to the domain. It's going in the other direction. Now the last part that this asks is to find the input. So find the x value over here that connects to the output value of negative 11. So for the normal function, whenever I plug that specific x value in, I should get negative 11 out. For the inverse, well, I can plug that negative 11 in to get back to the original input. So for us here, we can say f inverse of negative 11 is equal to negative 11 plus 5 over 3. And again, at this point here, we could plug this into the calculator. And indeed, it would give us negative 2. Because a negative 11 plus 5 is negative 6. And negative 6 divided by 3 is indeed negative 2. So the original input of negative 2 would have given us an output of negative 11 in our starting function. Any questions on this here? Both the ones circled. Does it ask for two things? Solve for the value of y, where f of x solving for the inverse, and then finding the input when the output is negative 11. Now, if we look back at the original problem, 3x minus 5, and I plug in negative 2. 3 times negative 2 minus 5. Well, 3 times negative 2 is, and negative 6 minus 5 is our output of negative 11. Input is negative 2. So our original input of negative 2 would give us an output of negative 11. Because again, they're going in reverse. Any questions on any of this here? So let's look at this next one here. We want to find the inverse. Solve for x, we're finding the inverse. And then find the input, or puts, when the output is 2. So our first main step is to rewrite f of x as y equals x minus 2. Then our next step would be to switch x and y. Because again, we're wanting to find the inverse, so we'll switch x and y. Now we need to solve for y, exactly. So now we would add 2 to both sides, telling us that y is equal to x plus 2. And really, to denote that this is the inverse, we will use our f inverse of x, which is equal to x plus 2. So that there is the inverse function for this here. Now the last thing we need to do is find the input when the output is 2. So really what we're finding is f inverse of 2. And f inverse of 2 would be r2 plus 2. And 2 plus 2 is 4. So the input is 4 when the output is 2. Any questions on any of this here? All right. So let's look at this next one here. F of x equals 2x squared. Now again, when we find the inverse, well, the first thing we can do is replace f of x with y. So we say y is equal to 2x squared. And then we would switch x and y, so x is equal to 2y squared. Now if we're comfortable understanding that f and x a y are the same thing, we could just jump to that second step. Because we could just go from f of x equals 2x squared to x equals 2y squared, because we know f of x is y, and we're switching it. We can do that in one step. If y'all feel comfortable doing that, go on and do that. If not, let's write out step by step. Now that we do have the variables flipped, we need to get y by itself. What's the first thing we can do? I would divide by 2, because it's going to be a little bit easier to get you simplify the exponents with radicals or squaring last if we can get it by itself, or as far along to getting it by itself first. Is here 2 divided by 2 will give us y squared by itself is equal to x divided by 2. Now we would square root, because we do have the y squared by itself, so we can square root both sides. Any questions on this here? Well, the square root of y squared gives us y. This will stop scrolling. Give us y is equal to, well, plus or minus the square root of x over 2. Because again, whenever we square root both sides, we have to add the addition or subtraction, which is just telling us that our f inverse of x is equal to plus or minus the square root of x over 2. Now we could rationalize the denominator, but we'll leave it in this form here. Okay, so we have this here. Any questions on how we found this inverse? Now realistically for this inverse, one of the things we would need to rationalize the denominator, also we do have to have a restriction that x has to be greater than or equal to 0, because we can't have a negative number inside of a square root. It comes out as imaginary, but at this point we're not too focused on that there. Now the other part of this was to find the input when the output was 2. So to find that input, we're just taking f inverse of 2, which is equal to plus or minus the square root of 2 over 2. And again, at this point here, we can't put the plus or minus, but we can definitely take the square root of 2 over 2 in the calculator. Which would be the square root of 1. And the square root of 1 is 1. So here we have answers, because it could be positive or negative 1. Either one of these inputs works for this here. And this here would be our answer. And the reason this works out this way is because, well, the original function does not have a function as an inverse. Its inverse is not a function. Because if we look at the graph of 2x squared, 2x squared's graph, we get this here. Now this here does fail the horizontal line test. We can draw a horizontal line and it crosses it twice. Specifically, I could say 5. Because I can draw a line at y equals 5 and it's going to cross that graph twice. So it doesn't have an inverse. Because the inverse that we found, second square root alpha y equals enter, because it's x over 2, because we had a positive case for it and we also had negative version, the plus or minus. So its graph would actually look something like this here, which, looking at that graph, the red and black lines, if we draw a vertical line, it would cross it twice, so it's not a function. So that's why the inverse doesn't have is not a function. We can still find it, it's just not a function. Any other questions on these here? All right, let's look at the next one. So we're going to find the inverse of this and then evaluate it for when the output is 2. Now the first main step, again, when finding the inverse is switching f of x with y. So y is equal to negative x cubed plus 3. Now our next step would be to switch x and y. X is equal to negative y cubed plus 3. Now what do we need to do next? We need to get y by itself. So what can we do first in getting y by itself? I can subtract 3, if it'll let me. Minus 3. Minus 3. And when we subtract 3 from both sides, we get that x minus 3 is equal to negative y cubed. What do we need to do next? To divide by negative 1, or we could multiply. Multiply or divide by negative 1. Either one works, because dividing by 1 really doesn't change anything, and multiplying by 1 doesn't really change anything. We're really just changing the signs, because we're changing it from negative y cubed to y cubed. What's going to happen to the x minus 3? It's going to become plus 3. Because that negative is just changing the sign. That's really all we're wanting to do. We're wanting to make the y cubed go from being negative to positive. But if I change the signs on one side, I have to change the signs on the other. Okay? Is y by itself? Well, no. We have what? The cubed, yes? How do I undo a cube? We cubed root it. We cubed root it. We don't match the colors. Cube. Rubik's Cube. Undo a cube. Yeah, no, it's lame. Yeah. Which just tells us that the inverse of this function, f inverse of x, is equal to the cubed root of negative x plus 3. Now, this one here, we don't need the plus or minus because of the fact that it's a cubed root. When we take the cubed root or an odd root of any number, we only end up with one real root. And this here would be our inverse. Well, now we just need to evaluate this when x is 2. When the x value, the inverse is 2, so f inverse of 2 is equal to cube root of negative 2 plus 3. Hopefully for this one here, we don't need a calculator to solve this one, because the negative in front of those parentheses is just going to make that 2 go from positive to negative, yes? What's negative 2 plus 3? What's the cubed root of 1? 1. So inverse of 2 is so our original function for this here was x cubed plus 3. So x cubed plus 3. Clear that out, clear that out. So if we look at this graph, so we have this here, yes? Does this fail the horizontal line test? Is there a line that we can draw that this graph will cross it more than once? Well, it doesn't look like it. I mean, when we get close to 0, maybe it does cross there more than once. Let's mess with the windows. So, and look from 2 to, let's go, actually I'm going to go from 1 to, not 4, 5. We're just zooming in on this spot here So that's a distance of 4. So let's say 0.4 and go from -1 to 1, which is a distance of 2, so 0.2, and graph. If I get the window. Because, okay, it'd help if I thought about this in the correct light, and this here would be our 1 enter 5 enter 0.4. There we go. So that there where it looked like it went straight for just a second, we do see that it's a little bit, actually it's still just slightly increasing, not increasing as fast when we get to that y-intercept, but it's still increasing. And if I did this again, essentially zoomed in on that spot, we would see, okay, it is still increasing, it's just not by a whole lot. Because that's what we were doing. We're just looking at that point right there, where it crossed the y-axis really close, to see, okay, it is still increasing. Now we found the inverse of it, which was the cubed root, math 4, of negative x plus 3, which is this here. It kind of looks like the same one as the graph of the blue, but it just kind of, fell over, didn't it? And incidentally, say, we'll go green. These here are actually a reflection across this line here. Any inverse is a reflection across the line y equals x. And they'll have a mirrored image of each other flipped. Because if we look at the one in blue, we flip it over, it's actually going to be that one in red. And that's for any inverse. Any questions on any of this here? Any questions on anything we've done so far? No? Now, hopefully most of y'all remember doing this in Algebra 1. Not so much with cubed roots and third powers, but especially with the linear functions and ending up with the fractions. So, we're not doing this one, that one, that one, that one. Because again, I'm going to condense these notes. I'm going to look back at all the note sheets and redo them, relook at them. I do want to look at this and one other today. We're going to look at 2 more, and then we are done for the day. Again, I did plan on this taking 2 days. Tomorrow's going to be real simple, real easy, and we'll be done. This here, find the inverse of f of x equals x squared, comma, x is greater than or equal to 0. Well, if we look at the graph x squared, and y'all don't have to graph this, I'm going to go on and graph this, x squared. I'll just graph the one in green because I'm already there. We have this here, yes? Does this function pass the horizontal line test? No, it crosses twice, yes? Now, in the instructions, it said f of x equals x squared, comma, x is greater than or equal to 0, yes? If we took that into account, I think this is here, lets me draw. What we're saying is all of this part of the function here is gone. Okay, I got it. So we're only looking for where x is positive, yes? If I remove that side of the graph, does it pass the horizontal line test? Well, yes, because I removed any of the spots where it crossed more than once. And that's what we really have to do to turn it in, its inverse into a function. Because that's what we have to do, is we have to remove that part. Okay, screenshot. And that's why they include this here. That's why when we looked at the one before with the radical, we had to kind of add that part in, that x has to be greater than or equal to 0 to actually see what the function is. Well, if we find its inverse, y equals x squared, well, we switch it, x is equal to y squared. Over here. Now to get y by itself, we have to square root both sides. And if we take the square root of both sides, we get that y is equal to plus or minus the square root of x, yes? Now, for this here, we don't need the plus or minus. This would just be positive. Now again, that just sounds like I'm making something up, yes? That I'm just deciding to throw the negatives out. But let's look back at this function here, because we said everything to the left of the y-axis is not included, yes? And when we talk about an inverse, we're taking the domain, the input values, and the output values and switching them. They're flipping, yes? In this part of the graph, the x values are all what? Positive, yes? And we restricted that so that the domain, the x values stayed positive. What are all the y values? They are all positive, yes? So, in the original function, the domain was all values of x greater than or equal to 0. And that mapped to the range, which are all values of y that are greater than or equal to 0, yes? And if we're flipping it, going the other way, for the inverse, what does that tell me about all the values of y? They all have to be positive, yes? And all the domain has to be. So is there any way that that could be negative? Well, no. So that's why for this here we don't have to include the plus or minus because it has to be positive. We're taking positive to positive values. So for our inverse here, f inverse of x is just the square root of x. And that's why we get that there. Because of those restrictions with what the values of x can be, it has to stay positive. Because the negative, if we had the negative square root of x, would have been dealing with the other half of that quadratic, the part that we removed. Any other questions on this here? That'll be nice. We'll look at this tomorrow. So we'll stop here for today.